This is my third video. If you haven't watched the other two, it may be worthwhile seeing the whole series and why calculus teachers are obsessed with conjugates when they are when they're teaching complex numbers. So I just want to look now in my third video. The major goal is to be able to expand a quadratic that has conjugates within it. So let's just think of two numbers here. Let's go with 2. Let's stay with some nice small numbers for a change here. 2 minus 3i, and therefore my other root needs to be a conjugate. Okay. The main reason for this is so that we will get real coefficients on our quadratic equation once it's all expanded. So setting that all equal to 0. Well, truthfully, I don't actually need to do that in this case because all I'm doing is I'm practicing expanding. I'm not trying to solve. So let's just quickly have a look at this. Obviously, we know what the roots would be in that case. So let's just have a look. I'm going to treat that complex number in there just as a number, okay? So don't panic about the fact that I've got all these terms here. So I'm going to go first, I'm going to flip back to FOIL. I'm going to go x squared, okay, x times x, and then I'm going to go minus 2 times x, right? So I'm just multiplying these fellas together, and then I'm going to multiply those outsides together, and so I've got minus 2 plus 3i times x, and then at the end I'm going to have 2 minus 3i times 2 plus 3i. Now, what am I going to have here? Okay, I've got x squared minus 2x's plus 3ix's minus another 2x's, and then minus 3ix's. I'm noticing some cancelling I can do there. And then at the end here, if you've not watched my last video, this step may confuse you a little, but basically I can go 2 squared plus 3 squared. Okay, that's going to go on the end there. And so now I just want to be simplifying this down a little bit. So I'm noticing I've got this and this that cancel. These two sort of complement each other. So I'm going to have x squared minus 4x plus 13. And that is now giving me, I've finished. Notice I've got a real number here, I've got a real number here. Now, if you really want to, you can go and you can try chucking a complex number into there. You could use two that are not conjugates. See, do you get real numbers here? Okay? I'm going to bet that you don't, but if you do, go back and check your maths again, and then check it again. And then if you're still getting that, then can you tell me first? Because, I'll go and tell the mathematical community and I'll get that Fields Medal I've always wanted. Okay, so comment underneath if you do manage to find two that work. Never mind. Right, okay, not going to happen. Please watch my 4th video in this 3-part series. I've just realized I've left one thing out. Okay, thank you.